really excited to have this. Not often that we have a group of places and spaces exhibit very different points of view in the same room. This is really a cool event. I want to Michael Hamburger on the end. He is a professor of earth sciences at Indiana University, where he has served on the faculty since 1986. He combines an undergraduate background in environmental sciences and Russian studies with graduate degrees in geophysics from Cornell University. His research interests center on natural hazards, including earthquakes, volcanoes, tsunamis, and landslides, and include field investigations in the Philippines, the South Pacific, Central Asia, and the US mid-continent. He has strong interests in the intersection of natural disasters, environmental challenges, and economic and social issues. During 2015-16 academic year, he served as a Jefferson Science Fellow with the US Department of State and as an Embassy Science Fellow with the US Embassy in Kathmandu, Nepal. He leads Indiana University's involvement in the State Department's Diplomacy Lab program, and since 2017, he has been one of the lead organizers of the science advocacy group, Concerned Scientists at IU. What is that about?
A moment where I've taken off my hat as a research scientist, hat as a citizen advocate. This was a group that started spontaneously in 2017 when there were a bunch of kind of perceived attacks on the validity of science and its contributions to our society. And what started as an informal get-together to discuss things turned out into a growing science advocacy organization with now 1,200 members and a pretty exciting history of engagement with national, state, and local science policy issues.
Thank you. We'll flow with this. I think we can. It is. Next up, we have Bruce Hare. He is the senior system architect, project manager at the Cyber Infrastructure for Network Science Center at Indiana University in Bloomington, Indiana, right here. Since 2004, he has been involved in creating software and visualizations, which he'll talk about later, both in an academic setting with Dr. Börner and in industry as a former CTO of Chalk Labs, LLC, a data analysis and visualization software company. He has a passion for creating beautiful, extensible, usable, and maintainable software. He has contributed multiple visualizations for the Places and Spaces exhibit and helped to architect and implement the latest macroscope kiosk software and SciMaps website. Next, we have John Walsh, the Hathaway Trust Research Center and Associate Professor of Information and Library Science in the Lay School of Informatics, Computing, and Engineering at Indiana University. His research applies computational methods to the study of literary and historical documents. He is an editor of digital scholarly editions, including the Petrarchive, the Algernon Charles Swinburne Project, and the Chemistry of Isaac Newton. He developed comic book markup language for scholarly encoding of comics and graphic novels, and TEI boilerplate for publishing documents encoded according to the Text Encoding Initiative. He is founding and current technical editor of Digital Humanities Quarterly, an open access online journal published by the Alliance of Digital Humanities Organizations. His research interests include computational literary studies, textual studies and bibliography, text technologies, book history, 19th century British literature, poetry and poetics, and comic books. And I want to ask you, since I have you here, so who is your favorite?
Swinburne would probably be not my favorite, the one I've studied the most, certainly.
Okay.
But I like, the second generation of romantics, Byron, Keats, and Shelley quite a bit as well.
Nice. Of that. Great, thank you. And then Yong-Yeol Ahn, he's an associate professor at Indiana University School of Informatics, Computing, and Engineering. He was a visiting professor at MIT during 2020-2021. His research focuses on developing network science and machine learning methods and applying them to complex social and biological systems. He is a recipient of several awards, including Microsoft Research Faculty Fellowship and LinkedIn Economic Graph Challenge. So thank you again. I'm going to go through, these are the maps that these folks contributed to, places and spaces. And I'd love to have sort of the story behind them, a little bit about how they came together, or maybe explaining something that is not immediately visible. And so what we'll do is, so for Michael, we'll have you just kind of take us behind the scenes of this map a little bit, tell us about the origin project. And then we'll advance that and we'll talk about what you're working on now. And I would ask people who are watching to submit questions as we go along. Any questions? And someone will be monitoring those. And we will pass them on to the panel. But let's start with Michael.
To stand up with the slides, or
Especially with the mask is really important.
okay, so I hope you can hear me now. This is an amazing thing to me. I just realized when this exhibition was set up that this is kind of a 20-year anniversary for this project, one that I got involved in during a sabbatical year in Boulder, Colorado, where I was working with colleagues from a scientific consortium called the UNAVCO Consortium. And these images here are still images from an interactive map program. It was developed by one of my co-authors, Lou Esty, named lovingly after his hero, Jules Verne. It's called the Jules Verne Voyager. The system still works, and I'm realizing now it was a project very much ahead of its time. It kind of maybe preceded Google Earth and other widely used tools in presenting this incredible new generation of high quality global digital data about the world around us. I, as a seismologist, was particularly interested in representations about earthquakes and earthquake hazards. So this main map here is a kind of compilation of global seismic hazard maps from different parts of the world. But this map tool involved a compilation of about a dozen different kinds of base maps, many different kinds of geophysical overlays, and at that time, a entirely revolutionary representation of dynamic movements of the Earth's surface using global positioning system measurements. So these arrows here allow us to estimate the motions of, for example, the Pacific plate in relation to the North American plate that we live on, and allows users to zoom in on any part of the world with very high resolution and use these variety of geographic, geophysical, geological, and even biological data sets to compare with one another. One of the things that I'm quite proud of is during this time there, I realized that the main tool that was developed by Lou and his colleagues was a little cumbersome. It was a Java-based tool and it didn't work on all platforms. And we developed a junior version. It's called the Jules Voyager Junior. And it uses basically pre-prepared JPEG images that can be easily overlaid on one another, so that, for example, a classroom, high school students could take these images, quickly make a map of earthquakes and plate movements in the Himalayan region. And to my surprise and amazement, all of these map tools are still functional now, 20 years later. I still use the Jules Verne Voyager in my undergraduate classes, and I think now many of the school teachers that we've worked with on outreach programs are still using the Jules Verne Voyager. So an exciting thing, one of the additions that Lou made is to develop a similar tool for looking at all of the major planets in the solar system, several with the moons of planets, and even a paleo Earth version, so you can make images of any part of the Earth at any time in the past. So It's in the era of digital map making. This is a pretty long-lived entity. It's been around for 20 years and is still finding a lot of active use, both for researchers and for educators and students.
How did you decide upon the presentation of this particular map? When people encounter it, in the exhibit, set up like this, how did you decide to?
So this is a little bit challenging, and probably for many of the map makers here, this is an interactive tool that's really designed for people to make their own maps and, play around with it, find an area of interest and zoom in on it and try different base maps and so on. This is a very tiny subset, and they're ones that relate particularly to my areas of interest. So earthquakes, tectonics, earthquake hazard that show both a global view that represents, again, at this time, a new compilation of data assembled from different parts of the world versus some of these more regional to more local visions of seismotectonics, the interaction of earthquakes and tectonic processes in different parts of the world. So maybe you might think of this as like an ad to lure the visitors to go visit the tool and start playing around with its capabilities.
I'd like to talk about
So this is now 20 years later. My interests have grown through several different areas of geophysics, but in fact, over the past several years, my latest interests have really focused on a very particular secondary effect of earthquakes. These are earthquake-triggered landslides. This is an image from one particular one a couple of years ago in Kumamoto, Japan. It turns out that landslides are an extremely dangerous and important part of the after effects of earthquakes. So this is a map of the world with a global compilation that I've done with several students and colleagues that is compiled not just by the number of landslides or the size of the landslides, but the impact, the number of fatalities. And you can see that some of these representing triggered landslides over the last 2 centuries have claimed in excess of 25,000 lives. So a significant effects of earthquakes around the world is these unexpected, unpredictable secondary effects of landslides. Over the last few years, with a PhD student, Anna Nowicki-Jesse, we've developed a globally applicable mapping tool that identifies once an earthquake has happened, in this case, a real earthquake in Chi-Chi, Taiwan in 1999. This map represents a graphical representation of the probability of landslides, earthquake-triggered landslides occurring around the epicenter of that earthquake, based not only on the seismological properties of the earthquake, but also the geographic and geological conditions on the ground. And this is the same map with the mapped landslides superimposed. So each of those black dots is one of the tens of thousands of landslides that occurred. And you can see, at least at this scale, there's a pretty good coincidence with the areas of high probability and the actual occurrence of landslides. And these last two, which aren't entirely well presented on this slide, are actually imaginary earthquakes. So there's been a lot of talk about the so-called Great Big One, the giant magnitude 9 earthquake that's expected off the Pacific Northwest. Well, we might anticipate the secondary effects associated with a future event. And this is the map of expected landslide activities in Oregon, Washington, British Columbia that might be triggered by a great earthquake like this. This tool has now been embedded in a suite of real-time tools operated by the U.S. Geological Survey. So immediately in the aftermath of an earthquake of significant size anywhere around the world, you will see, among other things represented, is a map of the likelihood of landslides, which can help emergency providers respond.
That's amazing. Wow. Thank you so much.
Yeah.
All right. We're going to move on to, oh, I like this is science-related Wikipedia activity, and this is Bruce. You can tell us a little bit about this.
Okay, great. Thanks, Todd. So I'm actually going to be doing a walk around at 2 o'clock, and I'll probably go into some more detail on this. So if anybody wants more information later, I'll be walking to some of the different visualizations I've done and that are hanging around Luddy Hall. But this one is called a science-related Wikipedian activity. I made this in about 2006, 2007. And there's a lot going on here. So essentially what we've done, we created a map of all of Wikipedia circa 2007. And so there are multiple layers here. So at the bottom layer, there are little bitty dots and bigger dots, but the bottom layer is the base map of Wikipedia. And each dot is an article, including the bigger dots, and they're drawn close to each other if they've been cited by, if two articles are drawn close to each other, if they've been cited by a third article pretty often. So that's the similarity metric that we use. We fed this into a layout algorithm called OpenORD. And so then you get this big ball, and then on the next slide and stuff, I can show you what it looks like. Yeah, so you get this big ball. And the original one, we printed a 5 foot by 5. This was intended to be printed. This was intended to be a printed visualization. It's 5 foot by 5 foot. We have a version of it out there that's about that size. And you can actually go back at that's ugly like that. And so then you have 600,000 Wikipedia articles. So what do we played around with this idea of we can use images as labels, so using image labels. And since things are similar to each other, it's kind of fun to say, look at one image and then see the stuff around it, and then you can sort of tell a story about it. And when you start looking through it, you'll see it, the bottom right has got more social studies, history, flags, maps. So history related stuff. Top left is more pop culture. And so the thing with this one is we're showing the math, science, and technology related articles. And I think we grabbed those by their Wikipedia category. You can categorize Wikipedia articles. So then you see there's a wide swath of math, science, and technology that goes through the center of the map. So then you can, it's just sort of a fun visualization. You can look at these, and then we have different ways. So they're size coded by this thing called edit activity. So we tried to find, so we use this measure to try and show what are the hot articles that people are talking about. So editing, we looked at edit history, and you'll get edit, this was back in 2006, 7. So even today, like these edit wars where people aren't on how things should go, or like if you ever look into religious figures or other figures, there's defacing and stuff, and so they get a lot of activity. So that sort of, this also has another layer of showing what is Wikipedia thinking about? What are the Wikipedians thinking about? So that's pretty much it. I guess you can go to the next slide. Oops, go back up one. This was featured. So this was featured on Wikipedia's annual report as well. And that was Jimmy Wales. This is the last page of their report. So imagine a world in which every single human being can freely share in the sum of all knowledge. And that's what we're doing. So, and then I have some gigapans. There's a link in there that you can go to that can zoom in and out on the, originally these were designed to be looked at physically, but you can also zoom in and out of them. I think this is Jesus. I can't remember. It's hard to see them. Usually you can just, like when they're printed out, you can really read them very quickly and see them. So it's harder. Yeah, and And
Go back to your, like, can you talk a little bit about bursts? I see.
oh yeah,
Explain that to people, what that
this was so this is another so we visualization. You usually, the first step is you just kind of suck in the data and start doing statistics and looking at how it's structured and try to understand it. So we often will run multiple different smaller visualizations, or even just writing out counts and stuff. But the burst activity is we're using this thing in the network workbench, or well, that Sci2 now, but that detects bursts of activity. So if they had fairly recent bursts of activity, they would be bigger. And I don't remember the details on the algorithm exactly, but basically that. And the future, like this is just a new scientist article that was written about this.
Oh, cool,
Yeah, someone else wrote it. So
All right.
Yeah.
Thank you. We appreciate that. Thank you. And once again, please put them in the chat, and I think Katy might be monitoring the chat, and we'll get those to the panelists. But now we'll look at
So in literature, frequently a writer or a literary movement or literary period is associated with a particular time or place different from their home time and place. Writers are inspired by past historical periods and so on. For instance, an idealized version of the medieval period inspired many 19th century literary and artistic movements like Romanticism, the Gothic Revival, pre-Raphaelitism, and the arts and crafts movement. So in this visualization, we're looking at two Victorian poets. Algernon Charles Swinburne is identified by red graphics and Robert Browning by blue graphics. On the right is a column of poems, about 70 poems. Down below, we have a timeline showing the temporal setting of these poems. So we have poems set in mythological Greece and Rome, the biblical period, a number of poems about particular historical figures in the Renaissance, and then other historical events like the French Revolution. So this is the timeline of where the poems are set. And then the map above is displaying where they are spatially. So we have poems set in the Middle East with biblical events, and Greece and Italy with the Renaissance. And Swinburne wrote an entire volume of poems about the 19th century Italian struggle, the political and military struggle for Italian independence and unification. So we have Italian poems with 19th century settings by Swinburne, and Browning was famous for his many poems about Italian figures in the Renaissance. So we have these other Italian poems set in the Renaissance for Browning. And that's the basics of the map. It was generated. I'm envious of people who have data sets to work with, because for all these projects I'm talking about, we have to generate our own data. So students went through and coded poems with the spatial and temporal settings. And then I worked with another team of students from one of our school's information visualization courses to generate a prototype map that was pretty similar to this. And then for this final version, I collaborated with Laura Pence, a local graphic designer, for this version that went in the exhibit. The limitation of this is the very small data set. There's about 70 poems total. Each of these poets wrote hundreds of poems, and they're just two poets out of many we could have represented. So it'd be really exciting to have an interactive map with thousands of poems by dozens or hundreds of poets, but the challenge is generating the data. Now, with machine learning, we might be able to do some automatic generation of those things, and that would be something that would be exciting to try in the future. If you want to go to the next slide, I have done a series of visualization projects with other teams of students from Katy's courses, and one visualizes a conceptual map of linking poems within a single volume by Swinburne. And then another one looking at my comic book scholarship, where we collected data from fan mail, published fan mail written to and published in the comic books. And we have maps of where these readers are writing from, demographics of, gender based on, first name of writers. Another network graph that shows the connections between readers and publications based on the fan mail communication. And all of these are done with the small handcrafted data sets. The published fan mail is out there, but it's not in digitized form. So we have to manually harvest names and addresses and that from digitized versions of the fan mail, or our own scans of paper copies. So that's.
So how is, well, I'll just ask you, so when I was doing, writing, I did it on fatherhood in the Romantic period, and it meant going through a bunch of books and scanning, but this was pre-digital, and looking for those. And it was, and finding one was such a great, you could add it to your, how has this changed? I mean, this is pre, digital humanities. I mean, how has this changed? Do people still do those kind of like studies of particular themes or particular issues? And how does that, the collection sort of help in that endeavor?
It's changed a lot. I think most humanities scholars still do that traditional work of reading literature manually and taking their own notes of what they find. What I do now, about 3 or 4 years ago, I became involved with the Hathi Trust Research Center, and that's the opposite of the handcrafted data sets. That's we create digital environments and tools and services to support computational research with the Hathi Trust Digital Library, which is 17 million volumes of digitized text. And a lot of humanities scholars do, you could do that kind of work you're talking about, looking at fatherhood or other issues within a subset of those 17 million volumes using computational tools. And inspired in large part, from the work I've done with these maps and with Katy and her students, we're currently building we just started building a dashboard of interactive analysis tools and visualization. So you could take a subset of those 17 million volumes. For instance, we have one subset that is based on Swinburne's personal library, about 2,000 volumes. That's we got that data from a sales catalog, auction catalog of his library being sold. And we can build visualizations to see what languages are represented in that library. Because there's, in addition to English, French, Italian, Greek, Latin, and other languages, or map the publication, the places of publication of the volumes, or a graph of the publication dates, and see a visual map of his library, his reading, the sources for his own writings.
Do we, if you're a scholar and you're using this, where do you go from here? You get this information, you get these kind of like periods that people are interested in. Where would you go from here? Would it be asking kind of why questions once you have the particulars?
Well, here is to look at these conventional narratives like Victorian medievalism, but map it out with the data and see, do the data support those conventional narratives. Because, Browning was writing about Renaissance Italy, and there's as much writing, or so much writing about classical Greek mythology and that in the Romantic period, and contrast that with like the neoclassical period, and see, do the data support these conventional narratives through literary history that are more subjective interpretations of the canon, or selective, right. And, bring in more writers, because of course, especially with novels, we study a handful of novelists when there were hundreds or thousands of people writing novels in the 19th century, for instance.
Great. Thank you so much.
Sure.
Sorry, we don't have those slides. I'll try to find them. So here's another from Places and Spaces of the Nation.
Thank you very much. So this is a visualization of basically how the mood changed throughout the day, and it was seen through Twitter. This whole visualization was conceptualized around the time when Twitter was kind of exploding in the popularity. Yeah, it's kind of unfortunate color scheme for colorblind people. Didn't know better. But yeah, by kind of mapping out those kind of mood with new techniques to kind of infer sentiment from text, we could see that there is a very clear like daily diagonal patterns, and it was really interesting to see that. If you go to next slide. So one of the inspiration was this study by Peter Dodds and Chris Danforth, who are at the University of Vermont now. And they looked at, so they basically come up with this really simple method to infer kind of happiness from text, and start to apply like really large corpus, and start to see like a really interesting pattern. If you, for instance, if you look at like online blogs, as the blogger age, you can see there's a kind of interesting pattern of like happiness like expressed in their writing. And if you look at the latitude, there's also this interesting pattern, and as well as kind of weekly pattern of happiness, you can see as well. So he presented this work at the time in our group when I was at Northeastern, and this was like really, really inspiring. Like, okay, now we have all this like really large text you can harvest from web, and then we can apply this type of text analysis method to kind of understand like what's going on as a kind of collection. And another inspiration was this article by Clive Thompson. And it was around the time where people start to kind of recognize Twitter as something, right? And you could still tweet by sending text messages. Well, that was like one of the main medium, a way to send tweets, not the mobile phone. We kind of, as a researcher in complex systems, we were very interested in like what's going on with Twitter. We joined pretty early. I have 2-letter Twitter username, YY, because I joined so early, like 2007, I think. And we were interested in Twitter as a kind of social sensor, like, because so many people, random people are tweeting. By looking at all these tweets and kind of combining them with like new techniques, maybe we can consider that as a kind of sensor that extract all kinds of information about the society. And at the time, another kind of really developed, which is called the density-based density equalizing cartogram. The idea was, okay, we can kind of reshape the map so that the area in the map, like state area of the state, represent the quantity we are interested in, like how many people there, for instance. So this kind of interesting new techniques and interesting data source. And I think it was just one random week that we get together to discuss like random ideas over coffee. And we came up with the idea that maybe we can combine all these things together, grab some tweets, put it in the state level, like location, and then just count number of tweets, calculate the sentiment, and let's see what happens. Yeah. So that was the visualization, essentially. If you go back, yeah. So yeah, that came about actually fairly quickly. One of the main reasons was that this guy Alan Mislov, he's like amazing computer scientist, and he could do a lot of stuff like really quickly. And yeah, so we put together all these ideas together and create a this map as well as a kind of movie that you can see setting pattern of the whole country. Like East Coast is waking up first, then 3 hours later, the West Coast is kind of bubbling up. People tend to be happy in the morning, and then it deteriorates. And then there's another kind of slight happier peak right after the work, but then it goes like deep dive after midnight. So that's like really interesting pattern we could like clearly see. Yeah. So yeah, if you go to yeah, after this, like recently I've been kind of thinking about these new possibilities, which is essentially artificial intelligence and machine learning techniques. And what they show is that, so this is a picture from like word-to-back method. If method, we can get the representation of words that encode interesting semantic relationship into geometric relationship in the vector space. Like you can find a direction that represent a gender, for instance, or different syntactic information or country, capital, and so on. So people have shown that this is possible using this new machine learning techniques. So one of the projects I'm working on now is that we are thinking this scientific enterprise, which is a really complex system that consists of like authors, papers, journals, funding agencies, countries. And we are exploring the possibility of, can we kind of embed and get the representation in the same space? So can we put all these entities into the same space to kind of basically reformulate a lot of questions about science of science? If you go to next slide, we published one proof of concept where each dot here represents a journal, scientific journal or conference, and they are kind of living in a vector space. And then we are showing in 2 dimensions. And this vector space captured a lot of interesting nuances. And it's thanks to the development of this new AI method. Yeah. Thank you.
I'll go back here. You have these tweets. What sort of standard do you use to like connect a particular word or usage of word with an emotion?
Very good question. That's what Peter Dodds and other colleagues suggested. So there is a emotional lexicon. So what that means is for each word, you can ask people, how happy is this word, right? 1 to 9. And then you can then average all these answers to assign a value. Like love, ranked pretty high, close to 9, 8. Or terrorist, maybe 1 or 2, like really low. So you can assign every word a value. And then the sentiment in the most like simplistic way, you can just think of sentiment of a text as the average of all the scores of the words. So that's what we use. Yeah, and it's really simple. And as you can see that it cannot be super accurate. But if you apply it to like large corpus with like billions of words, it tends to capture something about that corpus. And it also allows us to apply to big data set essentially, because it's so simple. Yeah.
When I show this to avoid doing business with these areas, for some reason, people kind of become more or less happy, I should say, as it goes along. And this is a particular unhappy. Yeah, this is fascinating. This gets a lot of attention in the exhibit. So, well, why don't we, or if any of the panel members have questions from the audience, we've got about 20 minutes left. So.
Audience, are there any commercial applications of the maps we just saw? And I think YY, you actually created a company, right? You were part of a company there. How did this go?
Yeah, so this map become popular, and basically we got together. Maybe there is some commercial application, not the map itself, but based on the idea of like using Twitter as a social media to extract interesting information. So we end up creating a company that basically provide analysis of social media data to other companies. Yeah, I mean, it was not, that was an interesting application. Yeah, thanks.
All right, this ball can be thrown. There's another question from an arts and humanities. Learn how to map. What can they do to get there? How can they get the skill to actually make a map? John, do you want to take that one?
Certainly, it helps to have colleagues like Katy and courses, in your institution where you can either take those courses yourself or collaborate with students in those courses. And then there's, I don't know if you're plugging this yourself, is the IV MOOC still going on? So
Courses in Luddy Hall which teach data visualization, information visualization, Unity. Actually, YY is teaching one of those courses. So we are fully covered here. And once every 2 years, we do a panel with all the teachers telling what courses offer what kind of hands-on experience or what kind of client projects. So I think within Luddy Hall, we are well. There are more and more online resources from lynda.com, but also from many other Coursera and other sites, which are in many cases free. And so you can just use them to get yourself that knowledge. But what's special about a trajectory that an arts and humanities scholar might take? What might be the first project they might like to take on?
Their particular, research interests, I've shown a couple examples here, but for instance, the historical novel would be another period or another genre that one could explore spatially and temporally. That would be an interesting avenue to explore. But it's, from my experience, it's a process of generating the data. Or if you have, again, smart colleagues who can help you generate some of that data with machine learning, that will speed things up. Another practical point, an increasing number of institutions have a digital humanities center or a digital scholarship group in their library that will help humanities scholars in particular get started with these types of projects, because they often don't have the same technical training that scholars from other disciplines might have. So that's another suggestion.
obviously the map making is not specific to science map making. There are many, many other maps, and we can learn a lot from cartography and geography. And there's also now more and more maps of the human body and many, many other data sets that exist in science. So I wonder what you all have learned from cartography and geography, or from other sciences that have made maps. And I don't know.
I come from a field, geology, that has a great history, in map making and using maps for spatial visualization, and maybe it comes more naturally to students in our field. However, I would say, one, that education is training. So the traditional kind of cartographic skills that were the bread and butter of training of students when I was an undergraduate are going out the door to some degree, and we're moving to a new generation of digital cartographers, or people who don't really know how to make a map but know how to superimpose information on a map. So now on your iPhone you might have Google Earth available and just have to add some observations to the pre-existing map. So one other thing that I would just observe over my time in this field is there's been increasing sophistication about map making in the media. And I'm so impressed by the stuff I see almost every day in, major digital newspapers and so on, is representation of political information, public health information, happiness or emotional kind of indicators. And it's a powerful way. I think we're all recognizing it's a powerful way to make sense of our complicated globalized world.
I was thinking about I think the first step, if you're wanting finding that thing that you're passionate about that you want to do something with. So gathering your data or having someone help you get that data. I was gonna say so it's totally random, but I had a bunch of Magic the Gathering cards. So it's a card game. And I wanted to sort it in a certain way, but I couldn't really figure out. So then I thought, okay, I wonder if there's data out there. And what do you know? Someone out there decided they wanted to put in digital form gathering card in a little JSON database that you could then, write programs about and get data out. So finding data is the number one thing. And then there's a lot of different tools that, if you're not a programmer, you can still feed it in, like Tableau, or even Excel is a great way to get started. And learning a little bit of statistics is very useful, because sometimes just being able to count things will get you pretty far. And so then, I think it's the same with programming. You just find one little thing and you keep adding on to it, keep figuring out that next thing. Okay, I can figure out how to put this in a spreadsheet and I can count it up. Next thing is, okay, now I want to make a scatter plot. Okay, how do I get that? I can look up in Excel's documentation. How do I choose 2 columns and make a scatter plot? So that's very useful. And then, the visual analytics certificate also from Katy's lab is a good start. We make different tools that we try to make as user friendly as possible. It has a low learning curve at the beginning, but as you get along, your use cases will get more and more advanced. It's the same with programming and data visualization. So.
I'm inspired by, I agree with how there's this explosion of visualization now, but I also like to look back through history and see how it's not a new thing. And look at old historical editions of the Bible, and you have these genealogical trees or an illustrated frontispiece where you have, all these different stories and themes and topics from the book represented visually in different ways. And we've looked at, I'm excited by computational, interactively driven visualizations, but also handcrafted things like the one map I showed, the science fiction map that is in the exhibits. So I just think there's so much to explore, and one can do this work, by collaborating with an artist in addition to collaborating a computational person.
Actually, I was intrigued by your Twitter happiness. It struck me that there's this new data set that people are mining these days from Fitbits and other kinds of physiological measurements. Can you somehow incorporate some physiological measurements into what's going on? And I'll just mention, maybe as a catalyst for another topic, people in my field have used it to detect when earthquakes are happening. So there are both physiological changes and Twitter, bursts that happen after big events like that.
Yeah, that's a really great question. Actually, we made another visualization after a couple of years after this, which was showing that actually tweet can be faster than earthquake.
Yes.
And actually Twitter used that as a kind of one of their ads, where someone pick up a phone, tweet about the earthquake, and then grab the coffee cup, and then earthquake shake the table. So we can actually see that, okay, here's earthquake hitting, and here's a wavefront moving, and then we can see the tweet about that earthquake happening before that front arrived to a certain state. So we made that visualization. So yeah, taking that aside, I think it's a really interesting possibility there, visualizing this health related data. And I think Strava is doing a lot of visualization in their Strava lab. So for instance, you can see heat map of like where people run, bike, and so on. One tricky thing is that there's a lot of privacy issues. There was one incident where I think army base was kind of revealed because there were many soldiers running in the track, and that was like leaked through Strava data, because you can kind of see the location and look at the map. But I think there are a lot of attempts to doing that, like looking at how people walk, for instance. One of my colleagues actually at MIT, they looked at the walking activity change during the pandemic. And then they showed that actually there were way more leisure walking during the pandemic, but there was a strong inequality in that. Like rich people essentially get outdoor more and walk more during the pandemic, but that's different from across like different income groups. So I think there is a lot of interesting possibility to study health, essentially health, happiness, and inequality using those data.
So I wonder if there is an easy way in for those which love visualizations and just want to see a few more visualizations after having seen some of the visualizations today. So are there online resources that you go to regularly, to some Twitter feeds or Instagram feeds, etc.? So what are the good ones out there which you can actually trust? Because there's a lot of misinformation out there also. I noticed that when we set up the Instagram account for managing the contest submissions, that there are many science publications which are extremely active on Instagram. And I learned that these institutions, which I admire, they post stories, which are a really odd thing. They are only live for 24 hours and then they're gone again. So in our world, we are trying to create forever, like 10 years, 20 years, 50 years. That's why we write books, for instance. And the concept of just a 24-hour story was a really unusual one for me. And maybe that just ages me. But ultimately, what I wanted to point out is that on Instagram, There are lots of really valuable sources that you could go to, but there might be other ones, websites or feeds that you could help people understand and get to. So maybe go another round here. Maybe you have your favorites or favorite conferences or events. Like I love the AAAS conference because it brings together 5,000 people which care deeply about science communication. How do you get from the academic institutions, from policy making, from other institutions to a better understanding by anyone about science and technology advances. So I don't know, maybe you can.
I have a good answer for that.
Well, for arts and humanities, there's an online journal, Cultural Analytics, and I would recommend that. And it's a lot of data-driven scholarship about the humanities, and within individual articles, there are different visualizations and that could be helpful or inspiring. With building this interactive suite of tools for HathiTrust Research Center, we've been looking at it's Observable or Observable HQ, and it's a platform for visualizations. And that's, I think, a good place to go and get ideas. And there's code you can reuse there and so on. So those are a couple.
I've already done a little bit of a plug for a remarkable, accessible program with incredibly high quality data that's available for virtually the entire world. And the way they have allowed other data users to superimpose other kinds of data on top of the topographic and Earth surface information there, I think is really incredible. And some of you may know Google Engine, I believe it's called, is basically a time history of the Google Earth images, which are really remarkable ways to visualize changes in our Earth. So you can actually, in a minute, you can see the process of deforestation of the Brazilian rainforest, or see changes in river patterns as they change their meanders, or jump from one channel to another. Human-made changes like the growth of megacities or wildfires and so on. And maybe last, a plug particularly for the New York Times. I feel like their data visualizations among the journals I see really stand out, and some of the stuff that's come out during the pandemic, I find quite powerful ways of imaging both the public health aspects and the political and social aspects that have really helped me make sense of it. And of course, I'm sure there are other journals around, but I think they've done a particularly good job.
Yeah, thanks. So I would also recommend New York Times and several other newspapers like Financial Times, Wall Street Journal, Washington Post. They have a really excellent visualization team. So kind of subscribing to their visualization will be really nice. And I think like what's nice about like Twitter and other social media is that you can kind of curate your own stream feed. And then you can follow those who curate other people. So you can follow curators of curators of curators and curators. So by building, identifying like people, like say if you saw like amazing visualization, figure out whether they have a Twitter or not, you can follow. And then you can start following the curators on Twitter. And I think subreddit, Reddit is also another great source. There are a bunch of subreddit, for instance, like Data is Beautiful. I think there are like a lot of interesting attempt visualizations happening there. So I think these are great resources. Yeah. Oh, and one really nice website is called Our World in Data. You probably know, and it shows a lot of amazing facts about our world essentially. And it's not only the data, the visualization, but also you can download all the data set behind it. You can kind of manipulate the visualization. So I think it's a wonderful platform if you're interested in anything about our world.
You gave up a busy time of year. I really appreciate it. This is great. It's going to be hard to top this hour, I think. But thank you so
Thank you.
Wait, there's one more for Todd.
Oh. Thank you.
Thank you so much. Thank you all.
We can take a group picture with the appendices.
Oh, yeah, I would love that.
All right. This is awesome.